All right, in class 1 we talked about square roots and radicals with square roots, and now we're going to talk about cube roots, fourth roots, and fifth roots. Now, on this page are some common ones. You now have a list of these, so you want to make sure you start to recognize them and know them. Cube root of 1 is 1, cube root of 8 is 2, and so on. It also has cube root of negative 1 equals negative 1, cube root of negative 8 is negative 2, and so on. With fourth roots, we like you to know up through 5, and fifth roots, the same thing, up through 5. Just be able to recognize them. Now, question for you. Why is it okay to take the cube and fifth roots of negative numbers, but not square and fourth roots of negative numbers? Yeah, because if you have negative 1 cubed, that's negative 1 times negative 1 times negative 1, that's negative 1. So we can do the cube root of negative 1 and get negative 1. Okay, so with odd number roots, it's okay to have negatives underneath. Even numbers, it is not. All right, so let's look at some problems. The cube root of 27. That 27 is on our list. Cube root of 27 is 3. This is just starting to be able to recognize them. All right, cube root of 48. Go back to our roots list. I know 8 goes into 48, and that's the only one. Okay, so when you have this cube root of negative 48, you can split that down to negative 8 times 6. So the cube root of negative 8 is negative 2, times that 2 is negative 4, times the cube root of 6. Next, the fourth root of 512. Well, let's go back to our list. The fourth root, 512, is not on our list. 256, well, 256 times 2 is not 512? It is 512, right? 10, 11, yeah, 512. So 512 is 256 times 2. The fourth root of 256 is 4. So 4 times the fourth root of 2. Next, we have the fourth root of 81 over 25. Now, this can be split up. Fourth root of 81 over the fourth root of 25. If we look back to our fourth root, the fourth root of 81 is 3. So, fourth root of 81 is 3. And then we have the fourth root. 25 can be written 5 squared. Now, we know we have to rationalize. We cannot leave a square root in the denominator. So, what we have here is the fourth root of 5 squared. We need to have a fourth. So what do we have to multiply 5 squared by in order to be 5 to the fourth? Yeah, we're going to multiply by the fourth root of 5 squared. Now this is a warning here. It happens to be that we're multiplying by itself. It not always is like that. Okay, so be careful there. So on the top we have 3 times the fourth root of 5 squared. Over on the bottom, that becomes the fourth root of 5 to the fourth, which is just 5. So we have 3 times the fourth root, 5 squared is 25, over 5. All right, the next one, we have the cube root of 7 over the cube root of 9, and I'm going to write 9 as 3 squared, because in order to rationalize, we need a cube, because it's a cube root. So we have 3 squared, so how many more 3's do we need to be 3 cubed? Yeah, just one more. So we're going to multiply by the cube root of 3. Underneath the radical, we can multiply, so we get the cube root of 21. And then on the bottom, this would be the cube root of 3 cubed, which is just 3. And that's it. Okay, so one more time. Over here, we multiplied by itself, only because it was 5 squared, and we needed a fourth root, so we multiplied by 5 squared in order to get 5 to the fourth. Here we had 3 squared. We need a cube root, so we need 3 of them. We needed one more to get us 3 cubed. Okay, so let's do some more of these. Fourth root of 32. Well, 32 we know is 2 to the 5th power. Okay, so when you're doing this, you can take out 2 to the 5th. If we're taking a fourth root, that means that is 2 to the 4th times 2. What's the fourth root of 2 to the 4th? That's 4 times the fourth root of 2. Now, we need to rationalize. Right now, we have 1, 2. How many more do we need to get 4? Yeah, 3. So we're going to multiply by 2 to the third. So we have 3 times the 4th root of 2 to the third over the 4th root of 2 times 4th root of 2 to the third is 4th root of 2 to the 4th, which is 2. So on the bottom we have 4 times 2, which is 8. So we have 3 times the 4th root, 2 to the third is 8, all over 8. And no, you cannot reduce. That's inside the radical, that's not. Okay. The next one, let's combine all of these together and reduce what we can. 2 times 2 is 4, so those cancel with the 4 and the 3's cancel. So on the top we have the cube root of 1. On the bottom we have the cube root of 5. Cube root of 1 is just 1, okay, but the cube root of 5 we need to then rationalize. How many more 5's do we need to get to 3? 2. So we're going to multiply by the cube root of 5 squared. So cube root of 1 is just 1 times the cube root, 5 squared is 25, over, this ends up being the cube root of 5 to the third, which is just 5. There you have it. All right, down here, negative 625. Let's go back to our list. Where is 625? 625 is the 4th root of 5. So that means 5 to the 4th equals 625. So on this page, that is the cube root of negative 5 to the 4th over 16 is 2 to the 4th. All right, so here we have 3 goes into 4 once, so we can take 1, 2 out, and then we have 1, 2 left over on the inside, and the same thing on top, 3 goes into 4 once, so you can pull out your negative 5, and once you pull out that negative, it's out, and you're left with the cube root of 5. From there, you have to rationalize. You have a cube root, you have 1, 2, so how many more do you need? 2, that is correct. So the cube root of 2 squared. So the cube root of 5 times the cube root of 2 squared. 2 squared is 4, so 5 times 4 is 20. So we have negative 5 times the cube root of 20 over cube root of 2 times the cube root of 2 squared is the cube root of 2 cubed, which is 2. So 2 times 2 is 4. And that's that. Alright, so next we're adding in some variables. Alright, with the variables, cube root of 24x to the 6th, separate them just as we did before with the variables. So the cube root of x to the 6th. With 24, what perfect cube goes into 24? 8. So that is, where am I? 8 times 3. So the cube root of 8 is 2. So that's 2 times the cube root of 3. Cube root of x to the 6th, 3 goes into 6 twice. So that is just x squared. So your final answer would be 2x squared times the cube root of 3. Okay. Next one, we have x times the cube root of 192x cubed. So looking at 192, 192, what goes into that? 64 times 3 is 192. So we have, this is 64 times 3, and then times the cube root of x cubed. Well, the cube root of 64 is 4. Don't forget the x on the outside. Cube root of 3 we don't know. Cube root of x cubed, 3 goes into 3 once, none left over. So that's an x. So on the outside you would have 4x squared, and on the inside the cube root of 3. Next, 4 goes into 512. Let's see, what goes into 512? We did that already. That was the 4th root of 512 is 4 times the 4th root of 2. Okay, so that's 256 times 2. And then the 4th root of 256 is 4. So we have the 4th root of 2 left over. And then with our variables, the same thing we did with squares. All right, you can do 4 goes into 7 once, and then there are 3 left over. So on the inside, you'd have x cubed. With a y, 4 goes into 8 twice, so you can bring a y squared out. None left over. With the z, 4 goes into 9 twice, and then you have 1z left over. Okay, so it's 4xy squared z squared times the 4th root of 2x cubed z. Now, let me break that down for a second. When you do the 4th root of x to the 7th, just in case you were confused what I was doing, 4 goes into 7 once, and then you'd have 3 left over. So that's where I'm getting the 4th root of x to the 4th is just x times the 4th root of x cubed. That's what was left over. Okay, just in case you were confused there. So that would be your answer there. The next one, 4th root of 3, we don't know, so that's going to stay in there. 4th root of x to the 7th, we just did that over here, right? 4 goes into 7 once, with 3 left over. With y to the 9th, 4 goes into 9 twice, with 1 left over. And then with z cubed, 4 doesn't go into that anytime, so that stays, z cubed. Not a fraction, so no need to rationalize or anything like that. That's it for your answer. Okay. Next, we have to rationalize some of these. So this first one is just multiplying, okay? But then, yes, we will have to start rationalizing. So, with 16 times 12, totally up to you if you want to keep them separate or combine them. I know that 8 goes into 12, so I'm going to split that out. Or 8 goes into 16, so I'm going to split that one up. Okay, cube root of 8 is 2, so I have 2 cube root of 2. And then I also had the cube root of 12. So that we'll deal with in a second. As far as your variables, I'm going to combine those. X cubed times x is x to the 4th. Y to the 4th times y is y to the 5th. And z times z to the 4th is z to the 5th. So, down here, getting this one going, we have 2 times the cube root of 24. 8 goes into 24. Cube root of 8 is 2. So we have 2 times 2, which is 4. And then inside the cube root, we have a 2, right? This 2 left over. So as far as our variables, 3 goes into 4 once, with 1 left over. 3 goes into 5 once, with 2 left over. 3 goes into 5 once, with 2 left over. That's how you solve that one. Okay. Next, if you can simplify inside, you do. This one cannot, but ones like these, you want to simplify inside first when you can. Okay, but starting with this one up here. No simplifying, so just break it up and do each one separately. Okay, on the top, cube root of 8 to the 5th times c. 3 goes into 5 once, with 2 left over, and you have a c left there. On the bottom, the cube root of 2d to the 4th. Cube root of 2, we don't know that, so that's going to stay on the inside. With d to the 4th, 3 goes into 4 once, so 1 comes out with 1 left over. We do have to rationalize, okay? When we rationalize here, we need 3, and you need 3 of each. So you need how many more 2's, and then how many more d's? Yeah, we need 2 more of each, so we're going to have 2 squared and d squared. So we're multiplying by the cube root of 2 squared and d squared. So, on the top, you have a squared c times 2 squared, which is 4d squared. On the bottom, this right here gives you d times the cube root. 2 times 2 squared is 2 cubed. D times d squared is d cubed. So on the top, just putting that in order, you have the cube root 4a squared cd squared over, on the bottom, this right here is 2d. So d times 2d is 2d squared. And that's it. Alright, I know this has been long, but 2 more. Here we go. Inside, simplify. X, one of those can cancel, and y cubed and y to the 8th. 3 can come out, you have 5 left on the bottom. So, we have the cube root of x over the cube root, I'm just going to write 4 as 2 squared, and y to the 5th. Alright, simplify there. The y to the 5th can be simplified. So that gives you the cube root of x over, not the 2 squared, so that's going to stay on the inside, but 3 goes into 5 once, so 1 can come out with 2 left over. Now, we need to rationalize. So how many more 2's and how many more y's do we need? Just one. We need to get to 3, so we just need one more of each. That's what gets multiplied on top and bottom. So combine on the top, you have the cube root of 2xy. On the bottom, that ends up being the cube root of 2 cubed and y cubed, which is just 2y times the y is 2y squared. Again, on the top it's inside the radical and the bottom not inside the radical, so cannot be simplified. Alright, and finally, x and x to the 5th can be simplified. That becomes x to the 4th, and y cubed and y to the 6th becomes y cubed on the bottom. So on the top we have 2x to the 4th, and on the bottom we have 3y to the 3rd. Alright, so on the top, the 4th root of x to the 4th is x. So that comes out, and we have the 4th root of 2. So the bottom stays this. Alright, now we have to rationalize. So, let's move that down here so we can now look to rationalize. Alright, so on the bottom, you have 1, 3. How many more do you need to get to 4? 3 of them. And you have 3 y's, so how many more to get to 4? Just 1. So to rationalize, you're multiplying by 3 cubed y. So on the top, we have x times the 4th root. 3 cubed is 27, so times 2 is going to be 54 times y over 3, that becomes 3 to the 4th, y to the 4th, and the 4th root is just 3y. And that's it. There's no 4th root that goes into 54. Just check and verify that. 1, 16, 81. None of those go into 54. Okay, so that is it. Alright, so there's your practice, or there's your lesson. Go ahead and try the practice worksheet now.